Probability. Introduction. The probabilities we have discussed in 9th standard were experimental or empirical probability of events, which were directly based upon the results of the actual experiments. Let us carry out an experiment. Toss a coin 1000 times. Then the frequencies of the outcomes is given below. Head 465, tail 535. Based on this experiment, the empirical probabilities of a head is equal to 465 upon 1000, which is equal to 0.465, and the empirical probabilities of a tail is equal to 535 upon 1000, which is equal to 0.535. These probabilities are based on the results of an actual experiment of tossing a coin 1000 times, and hence they are called experimental or empirical probabilities. In fact, experimental probabilities are based on the results of actual experiments and adequate recordings of the happenings of the events. Moreover, these probabilities are only estimates. If we perform the same experiment for another 1000 times, we may get different data giving different probability estimates. In 9th standard, in activity 1 and activity 2, we have tossed a coin many times and observed the number of times it turned up heads or tails. We also observed that as the number of tosses of the coin increased, the experimental probabilities of getting a head or tail came closer and closer to the number 1 upon 2. Many other persons from different parts of the world have done this kind of experiment and recorded the number of heads that turned up. For example, the 18th century French naturalist Comte de Buffon tossed a coin 4040 times and got 2048 heads. The experimental probabilities of getting a head in this case was 2048 upon 4040 is equal to 0.507. J. E. Kerrich from Britain recorded 5067 heads in 10,000 tosses of a coin. The experimental probabilities of getting a head in this case was 5067 upon 10,000, which is equal to 0.5067. Statistician Carl Pearson spent some more time making 24,000 tosses of a coin. He got 12,012 heads, and thus the experimental probabilities of a head obtained by him was 12,012 upon 24,000, which is equal to 0.5005. Now, suppose we ask, what will the experimental probability of a head be if the experiment is carried on up to, say, 1 million times or 10 million times, and so on? You'd intuitively feel that as the number of tosses increases, the experimental probabilities of a head or a tail seems to be settling down around the number 0.535, that is 1 upon 2, which is what we call the theoretical probabilities of getting a head or getting a tail, as we will see in the next section. In this chapter, we will introduce ourselves to the theoretical or classical probability of an event and will also discuss simple problems based on this concept.